So we're going to be talking about the normal distribution and finding x values for random variables in this one. So in the past, what we've done, we've been given a random variable and we found the z-score, and then we got the probability from that. Now we're going to start with the probability, and then we're going to find the z-score, and then we're going to work our way to finding the x value. So we're literally doing the opposite, okay? So first thing we're going to work on is trying to find the z-score, okay? And it corresponds to the area given here. So cumulative area, so I always draw my picture. What's in the middle? 0. Now, 70% cumulative area, this is area to the left. If 70% is to the left, that means I'm on the right side, okay? I just don't know where. I just know that more than half of it is going to be shaded. Okay, so this is 0.7019. So now all I need to go do is go look at my table and play Where's Waldo and find the 0.7019. So let's try that out. So let me delete that. So 0.70. So it looks like the 7s are in this range here. Okay, bingo, 7019. So what is 7019? 7019 goes to 0.53. 0.53. Okay, 0.53. So that is the z-score, 0.53, associated with it. Now, if the probability given is not in the table, then use the closest z-score. So use the closest z-score if it's not in the table. If it's exactly halfway between two, then use the average. Okay, and if you think about it, like if it was 0.9500, that one is that tricky one, right? 0.9500. Right here we have 9495 and 9505, right? So halfway between 1.64 and 1.65 is 1.645. So use the average. So this would be 1.645. Okay, that's the average of 1.64 and 1.65, right? So it's the halfway between mark. So halfway between, average your z-scores. Average the z-score. All right? So what I want to do is I want to find the z-score that has 11.21% of the distribution to the right. So I always draw my picture first. When I draw the picture, it gives me a better idea of what's going on here. So 11% to the right, that's going to be smaller than half. So I want less than half to the right. So I know it's going to be somewhere over here. This is 0.1121. In decimal form, always convert to decimal when we're talking about this probability. So all you got to do is move the decimal place over 2 to get 0.1121. Okay, if that's over there, then what's on this side? Use the complement rule. 1 minus 0.1121 gets me 0.8879. So what do I need to do? I need to go look up the number for 8879. So I go play Where's Waldo. So 8879, that's going to be somewhere on the right side. So 8879. 88698888. Okay, which one is it closer to? 0.8869 or 0.8888? Which one is this one closer to? If I subtract, so if I subtract off 0.8879 here, I'm going to get, I guess, 0.0010 negative. And if I subtract off 0.8879 here, what do I get? Well, I would get 0.8888 minus 0.8879, which is 0.0009. Okay? So that is tiny. Okay? So that's, both of those are small. Now, technically, this one is closer. Okay? So technically, I would agree with you that this is closer. So your z-score that corresponds with that, I believe that z-score is 1.22, and I believe this z-score was 1.21. So technically, I would not count you wrong if you got that one. Okay? Now, maybe a better estimate, since you notice that these are almost identical distances apart, it might be best if you average them. Okay, so it might be closer if you actually average though, which would give you 1.215. Okay, if you actually did this in the calculator and you did your normal CDF, you might find that the 1.215 is a better estimate than the 1.22. Okay, since it's so close to being right there in the dead center. All right, so I would probably take either this answer or this answer. And, you know, if I was feeling really nice, I'd take this answer. But the reason I lean against taking that 1.21 is because this is actually closer technically than that one, even though it's by a slim, very slim 10,000th margin. Okay? So that's just something that, you know, pops up. All right? Now, once again, I keep stressing this because it's so important, but this P subscript 95 stands for 95th percentile. 95th percentile. I cannot tell you how many times we use this, all right? This means that 95% of the data is to the left of P95. Okay? That represents 0.9500. And when you go look this up in the chart, just like we just did, right? We find that it's right there in the dead center. It's the average. The z-score that corresponds to this is C equal 1.645. Okay, you ought to just memorize this due to how many times you have to use this for the percentile. All right, guys, hopefully this helps you a little bit more in finding z-scores. And now we're going to transition. We're going to do a problem where we're actually given the probability. We can actually go from the probability to the z-score to the x value.